Hello students, today we are doing a theory question. Actually it's from circular motion. You can read the question on the screen soon. This question actually I picked because it covers so many theories. So let's get into the question. You give it a try as usually. Just look at the question, give it a try, then follow the guide, right? This question is not, I'm not telling that it's difficult, but it covers lots of theories. Let's go with it, right? I hope you have tried it now. If you could get the answer, yes, that's good, that's great. So let's get into the question now. Right. Let's look at the actually the data given actually. Let's see. So first thing actually they are giving us this distance 50 centimeters. So they are asking us the unstretched length. So what basically actually what we have to do is we have to find the stretched length, right? If you could find the stretched length, then we can find the unstretched length, right? So I'm starting the question from here. They have given us the spring constant, so F equals kx, right? So if I can find the force when it is in the rotation, actually if I can find the force, then what I can do is I can find x value, the extension value. So 50 minus x, actually we will be getting the unstretched length, right? So let's find the F value. So let's apply, we have to apply it for the circular motion, right? So circular motion, F equals mr omega square, right? Actually omega is not given, but we are given this in 2 seconds we get a complete cycle, right? So 2 seconds, 1 complete cycle. So that means within 1 second actually, for 1 cycle mean angle 2 pi, that divided by 2 pi radius minus 1, that is the angular velocity. So we have omega value and we have m value and of course we have r value, right? So let's try to find f value here. So first thing, m, let's apply mass actually 500 grams, that also we have to convert it anyway. So it's in kilograms, it's 0.5, or let's say we don't know r, and omega value of course it's pi squared, that is basically f. Let's apply f equals kx here now, right? 0.5 that is given, actually 50, r is given 50 as in 0.5 meters, that into omega squared phi squared. Actually we are supposed to get phi squared as 10 in the data is given, and kx, so the value of k is here we have 50 into x. So let's simplify it now. 10 into 0.55, so 5 into 2.5 equals 50 x. So we are getting the extension here. So let's move up to here. So here what we are getting, x equals 2.5, I hope you can see it, divided by 50. So I'm getting x equals, I multiply this by 2, I multiply this by 2, I get 5 divided by 100, so it's 0.05 meters. So this is the the extension value, right? We have the value now, so we have x value. So 50 centimeter minus this centimeter is 5 centimeters, we get the answer 45 centimeters. Actually this question is a good question. I'm not saying that's a very difficult question, but we have to gather so many theories, right? In the MCQ paper, in the real A-level paper, we will be getting questions like this. So if you can gather the theories together, you are good to go with it. So it's a good question. Let's go through it with it again. If you couldn't do the question, if you could do it, that's great. Student, remember that there are plenty of questions I have given simply like this. So go through with the playlist, you will find good questions.